Hello all, welcome to the course Python Programming for Beginners. We are in Module 4, Python Operators, Lecture 1. In this lecture, we will be discussing about Introduction to Operators, different types of operators supported in Python, Arithmetic Operators, Comparison Operators, Assignment Operators, and Logical Operators with examples. Python operators are used to perform various types of operations on operands. Consider an expression 10 star 2. In this, 10 and 2 are called as the operands and the symbol star is called as an operator. In another example, minus 20, 20 is called as the operand and minus is called as the operator. If you look at these two expressions, star is taking two operands, that is why it is called as a binary operator. On the other hand, minus is taking only one operand. That is the reason why it is called as a unary operator. Python supports different types of operators, including arithmetic operators, comparison operators, assignment operators, logical, bitwise, membership operators, and identity operators. In this lecture, we'll be covering up to the logical operators, and the remaining operators will be discussed in the next lecture. Python arithmetic operators are used to perform the following arithmetic operations, including addition, subtraction, multiplication, division, modulus operation, exponentiation, and floor division. And the symbols that are used in the programming for all these operators are plus for addition, minus for subtraction, star for multiplication, slash for division, percentile for modulus operation, double star for exponentiation, and double slash for floor division. Consider the examples for these operations. When the two operands are 5 and 4, 5 plus 4 results in 9 and 5 minus 4 is 1. 5 star 4, which is multiplication, is 20. 15 slash 3, which is the division, and here the quotient of the division is the result, and hence we got 5. Then, coming to the modulus operation, it returns the remainder of the division. So, once you divide 16 by 3, the remainder being 1, the result is 1 here. In the expression 5 double star 2, double star is exponentiation, that is 5 is raised to the power 2 and the result is 25. In case of floor division, whatever the quotient that we get out of the division operation, the decimal portion will be truncated in the result. Hence, 18 double slash 4, which is a floor division, though the actual quotient is 4.5, the result is 4. That means 0.5, which is the decimal portion in the quotient, is truncated. Let us look at an example program wherein we are taking the input from users A and B, and we are performing all these arithmetic operations on these operands. And then we are printing the results of all these arithmetic expressions. Print A plus B. We use double quotes in order to print the expression as it is, and then followed by the result of the expression by giving the exponent as it is in the print statement. Then we are printing the value of A minus B by giving the expression A minus B, and then we are printing the result of multiplication, then result of the division, result of the modulus operation, result of the exponentiation, and then finally we are printing the result of the floor division by writing A double slash B equal to followed by the expression A/B. For the two inputs A and B, which are 18 and 4, the result of A plus B is 22. A minus B, which is 18 minus 4, is 14. 18 star 4 is 72. 18 divided by 4, which is 4.5. And A percentile B, which is 18 percentile 4, which is the remainder here. So the result is a remainder, which is 2. And A is raised to the power 2. That is why the value of A, which is 18, is raised to the power 2 and the result is 324. And then A/B, which is a floor division, which results in only the whole part and the decimal portion will be truncated in the result. And this program will execute in the Google Colab at the end of this lecture in the form of a demo. Next type of operators are the comparison operators. Python comparison operators, which are also called as the relational operators, are used to compare the values that are present on either side of the operator. These comparison operators include is equal, is not equal, is greater than, is less than, is greater than or equal, is less than or equal. And the corresponding symbols that are used are double equal to. This is a not symbol, not equal to, then greater than, then less than, greater than followed by equal to symbol, and less than followed by equal to symbol. Let us check the result of the expressions after applying the comparison operators on 10 and 20. 10 double equal to 20 checks whether 10 is equal to 20 or not. So if the condition is true, that means if both the values are equal, the result is a Boolean value which is true. If they are not equal, then it returns false. For example, 10 double equal to 20 returns false because they are not equal. Then 10 not equal to 20, it returns true because of the fact that 10 is not equal to 20. Similarly, 10 greater than 20 returns false, 10 less than 20 returns true, 10 greater than or equal to 20 returns false because 10 is neither greater than 20 nor it is equal to 20. And the last expression, 10 is less than or equal to 20, returns true because though 10 is not equal to 20, 10 is less than 20. So it checks whether it is less than or equal to. So in either case, if the condition is true, the result will be a Boolean true value. And here is an example program for comparison operations. Here also we are taking the inputs from the user into the variables A and B, and we are performing the comparison operations A double equal to B, A not equal to B, A greater than B, A less than B, and A greater than or equal to B, and A less than or equal to B. So in all these expressions, the values of A and B are same. So once we execute the program, it will prompt the user to enter the values for A and B. In case if the user enters 10 for A and 20 for B, the expression, which is the application of the comparison operator double equal to on the variables A and B, it returns false. Similarly, A not equal to B returns true because 10, the value of A is 10 and the value of B is 20. And 10 is not equal to 20, which is true. Similarly, 10 is greater than 20 in this case, which is false. Since 10 is less than 20, the expression returns true. Similarly, A greater than or equal to B, that means 10 is greater than or equal to B, which is a false statement. Similarly, 10 less than or equal to b, it returns true. So this is the output we get whenever we execute the program. Next category of operators are the assignment operators. And these assignment operators are used to assign the values to the variables. There are so many assignment statements in addition to equal, which are called as shorthand assignment operators, which combines both arithmetic operation as well as the assignment statement. So we have different types of assignment operators, including the simple assignment, then addition assignment, subtraction assignment, multiplication assignment, division assignment, remainder assignment, exponentiation assignment, and floor division assignment. So in all these cases, the expression a equal to a plus 10 in the shorthand notation can be written as a plus equal to 10. So this plus equal to is the addition assignment. Similarly, a equal to a minus 10 can be written in short as a minus equal to 10, which is equivalent to a equal to a minus 10. Similarly, a star equal to 10 is equivalent to a equal to a into 10. Same is the case with the rest of the shorthand operators. Basically, all these operators combine both arithmetic as well as assignment operators. And here is an example program where we are assigning the value of 20 to A, and then we are printing the simple assignment value. Since 20 is assigned to A, it simply prints the value of A. And then after applying all the shorthand assignment operations, including addition assignment, subtraction assignment, and other assignment statements, we are printing the respective values of A. So let us observe the output of this program. Initially, A is assigned the value 20, and after applying A plus equal to 10, which is equivalent to A equal to A plus 10. Since the value of A is 20, 20 is added to 10 and the result is 30. And this new value of A will be used in the next expression. That means A minus equal to 10 is equivalent to A equal to A minus 10. Since the value of A is being updated as 30, 30 minus 10, which is 20 here. Similarly, this new value of A will be used in the next expression, because in all these expressions we are using only a single variable A. A star equal to 10 is equivalent to A equal to A star 10. That means the value of A is multiplied with 10 and assigned to A itself. Since the previous value of A is 20, 20 is multiplied with 10 and the value of A is updated as 200. Similarly, A slash equal to 4, which is equivalent to A equal to A slash 4. That means 200 is divided by 4 and the quotient is 50. And A percentile equal to 6, which is nothing but A equal to A percentile 6, which is 50 percentile 6 in this case, and it returns the remainder. So the remainder of 50 divided by 2 is 50 divided by 6 is 2. Similarly, A double star equal to 2. That means the value of A in the previous expression, which is 2, is raised to the power of 2. And the result is 4. And in the last expression, which is floor division assignment, A equal to A double slash 3. That means 4 double slash 3, which results in the quotient after truncating the decimal portion. So the quotient is 1.33, and since the decimal portion is truncated, we are getting only 1 as a result of the floor division between A and 3. And the next category of operators are the logical operators. In Python, logical operators are used in general along with the conditional statements for representing either a true value or a false value. And before proceeding to the programmatic representation of these logical operators, let us first understand what are these logical operations and or not in the form of a truth table. So here the inputs x and y are the inputs which can have only the Boolean inputs. Boolean means either 0 or 1. So 1 is represented with true and 0 is represented with false. So if both the values are true, then only the value of x and y will be true. And for all the remaining combinations of x and y, the output of the AND operation, which is x and y, are false. Similarly, for the OR operation, the result will be false only when both the inputs are false. In all other cases, the output is true. That means even if one of the values are true, the result of the OR expression will be true. Similarly, we have another operation which is a NOT, which is nothing but the inversion operation. If the value of x is true, then NOT of x will be false. If the value of x is false, then NOT of x is true. Similar is the case with NOT of y. So having understood the logical operators, how they give the output, let us observe an example program by taking two input values a equal to 5 and b equal to 9. Observe here we are using this logical operator along with the conditional statement if. Anyway, we'll be discussing about the if and else constructs in the subsequent lectures. For now, you understand that here we are only checking the condition whether a is greater than or equal to greater than 0 and b is greater than 0. So the result of this expression will be true only when both the values are true. That means a greater than 0 should be true, then b greater than 0 also should be true. Only then the if statement will be executed. Even if one of the expressions results in false, then the control goes to the else portion and executes the statements that are present under else construct. In this example, 5 is greater than 0 and 9 is also greater than 0. So both of them are true and the resultant expression is also true. So it executes the corresponding statements that are present under the if construct, which is here the print statement, and it gives the output as A and B are positive. Let us observe the output by modifying the value of B as 0. So in this case, A greater than 0, which is 5 greater than 0 is true, but B is greater than 0. Since the value of B is also 0, 0 can't be greater than 0. That is why this expression evaluates to false. And as we have seen in the previous truth table, even if one of the inputs are false, the entire expression of AND operation will be false. That is why the control goes to the else portion and executes the statements under else construct. Here we have the print statement, either A or B are not positive. That is why we are getting the output as either A or B are not positive. Now let us observe another example program which uses the OR operation. In the previous example program, we are using the AND operator, and now we are using the OR operator. When A equal to 5 and B equal to 0, in this case, though the second expression is false, the first expression is true. And the result of OR operation will be true even when one of the inputs are true. Since A greater than 0 is true, the entire expression evaluates to true and it executes the print statement A or B are positive. That is why we got the output as A or B are positive. Let us see one more example program that uses the NOT operation. Here A equal to 5, B equal to 0 and C equal to -2. And we are printing the values of NOT of A, NOT of B and NOT of C. And you please understand that only the values 0 and none are considered as false. And all the remaining values, which includes floating point values, characters, complex numbers, strings, all these are considered as true only. So, among these three inputs, 5 and -2 are true values and only 0 value is considered as false. That means A and C are true and B is false. So if we apply the negation, NOT of A is false because A is true and NOT of B is true because B is false and NOT of C is false because C is true. Though it is a negative value, it is considered as true value. Now let us see the demonstration of all the example programs that we have seen. This is the example program for arithmetic operators and here is the statements for taking the inputs for A and B. Then we are printing the result of addition operation, printing the result of subtraction, printing the result of multiplication, and here we are printing the result of division, and here we are printing the result of modulus division or modulus operation. Then we are printing the result of exponentiation and printing the result of A/B. So once we execute the program, it will prompt us to enter the values of A and B. Let me enter the value for A as 14 and then the value for B as some 3 and then let us observe the output of all these arithmetic operations. 14 plus 3, 17, 14 minus 3, 11, 14 multiplied by 3 is 42. And if you observe A/B, it is printing the decimal portion also. Whereas if you look at the floor division, the decimal portion is truncated and we can see only the numerical part. Then A percentile B, which is the remainder, after dividing 14 by 3, since the remainder is 2, it is printing 2. And similarly, the value of a is raised to the power 2, which is 14 raised to the power 2, which is 196. So there is the example program for arithmetic operations. And now let us check the Python comparison operators and execute it. Before giving the input, let me explain. Here we are prompting the user to enter the values for a and b, and here we are printing the result of a double equal to b. Now printing the result of a not equal to b, then print the result of a greater than b. In all these cases, the output is a Boolean value, which is the result after comparing the values that are present on either side of the comparison operator. The condition is true if both of them agree on the operator, then it returns true, else it returns false. Now let us enter the value for a, which is let's say 10. Then enter the value for b, which is 15. And then let us observe the output. Let us observe the output here. A double equal to b is returning false because a is not equal to b, and a not equal to b returns true. 10 is not greater than 15, that is why it is returning false. 10 is less than 15, that is why the statement returns true here. Similarly, 10 greater than or equal to 15 is false, and 10 less than or equal to 15 is true. Next, let us check the Python assignment operators, where we are assigning, we are using the simple assignment and also the shorthand assignment operations, which combine both arithmetic operations as well as the assignment operation. So let us check the output. Here a is initialized to 20, and after that we are applying the shorthand assignment, which is a plus equal to 10, which is addition assignment. Then we are applying subtraction assignment by using a minus equal to 10. Then multiplication assignment and other shorthand assignment operations. Let us observe the output. A value is given as 20. A plus equal to 10. That means a equal to a plus 10. 20 plus 10 is 30. And a minus equal to 10, which is a equal to a minus 10, which is 20 here. And a is multiplied with 10. 20 is multiplied with 10, and the result is 200. And a is divided by 4. It is equivalent to a equal to a divided by 4. So 200 is divided by 4, and the result is 50. And then 50 is divided by 6, and the remainder is returned here. So since the remainder is 2, the result is 2. Then a is raised to the power of 2. That means 2 is raised to the power of 2, which is 4. And 4 is applied the floor division by 3. So since the value of the quotient is 1 point something, and the decimal portion is being truncated here, the floor division returns the quotient after truncating the decimal portion. That is why the result is 1.0. Next one is Python logical operators, a equal to 5 and b equal to 0. And we are printing the values of not of a, not of b, and not of c. So only b value is false here, and c value is also false because this is null. So if we apply not operation on b and c, it should return true. So we can observe true for not of b and not of c. And 5 is true, that is why not of a is false. So with this demo, we came to the end of this lecture 1, and we'll see the remaining operators in the next lecture. Thank you.